Hello and welcome to a video on factorising quadratics using something called the sum product rule. Now before we get into what this is and before we look at factorising something like this, let's just remind ourselves how we factorise something. So something simple like this here. Now when we factorise anything, we're usually looking for the highest common factor of both terms and we just divide by that highest common factor. So with this expression here, what's the highest common factor of 4x squared and 6x? Well, if you think about the numbers first, the highest common factor of 4 and 6 is 2. So we know we can divide both terms by 2. But we can also divide both terms by x because we've got x squared here and x here. So we can actually divide both terms by 2x. So if we divide both terms by 2x, what are we left with in our brackets? Well, 4x squared divided by 2x. That just gives us 2x. 4 divided by 2 is 2, and x squared divided by x is x. And then we've got 6x divided by 2x, and that is just 3. So we're left with 2x plus 3, because the x's cancel out. All we're left with is 6 divided by 2. So this is how we would factorise something like this, and this is how we factorise most things. But when we get onto quadratics that look like this, we use a slightly different technique, and what it's called is the sum product rule. I'll explain exactly what that means. So in order to factorise this quadratic expression here, I need to find two numbers whose sum is this number, so 9, and whose product is this number here, which is 18. So I need to find two numbers that add together to get 9 and multiply together to get 18. So what could those numbers be? Well, the ones that multiply together to get 18, let's write those down first. So we could have 1 and 18, we could have 2 times 9, or we could have 3 times 6. So these are my possibilities, but which one of these pairs gives me a sum of 9? Well, 3 and 6. Okay, these ones when added together give us 9. Now I've identified which numbers I'm going to use. To factorise this expression, all I do is I write it like this. X plus 3 in one set of brackets, and then x plus 6 in my other set of brackets. All I've done is I've put these numbers into these brackets. And this is my fully factorised answer. And we can always check our answer ourselves by doing the opposite of factorising, which is expanding. So if I expand these double brackets, I should be left with my original expression. So let's just try that. X times x is x squared, and I'm just using the FOIL technique. X times 6 is 6x. 3 times x is 3x. And then 3 times 6 is 18. And I can just simplify this. 6x plus 3x gives me 9x. So I'm left with x squared plus 9x plus 18. And that is exactly what I started with. So I have factorised this correctly. So let's do another example. This time we've got x squared plus 2x minus 24. And I want to factorise this expression. So I need to identify two numbers whose sum is positive 2 and whose product is negative 24, and make sure you include that sign in front of the number because a term always includes the sign in front of it. That's negative 24. So which two numbers multiply together to get negative 24? Well, I could have 1 and negative 24. Remember, one of them has to be negative because whenever we multiply a positive and a negative, that gives us a negative. Or we could have negative 1 and 24. We could have 2 and negative 12, or we could have negative 2 and positive 12. If we think about 3 and 8, we could have 3 and negative 8, or we could have negative 3 and positive 8, or we could have 4 and negative 6, or we could have negative 4 and positive 6. And notice how all of these combinations, we've got 8 different combinations, all of these give us a product of negative 24. But now we just need to identify which one of these pairs gives us a sum of positive 2. So these ones here, they give us a product of negative 24, and they also give us a sum of positive 2. So these are our two numbers that we're going to put in our brackets. So to factorise this expression, all we do is we write x minus 4 in one bracket, and then x plus 6 in our other bracket. And again, we can double check our answer by expanding the brackets. And again, that is what we were originally starting off with. So we know that this answer here is correct. We've factorised it fully. Okay, let's do one more worked example and then I'll give you a few to do yourself. So we've got this expression here and we want to factorise this. So we want to find two numbers whose sum is -8 and whose product is +15. Now you might be thinking, well, two numbers that multiply together to get 15, how can I possibly get two numbers that add to get a negative number? Well, the only way to do that is if both of these numbers are negative, because we know that two negatives multiplied together give us a positive number. So we need two numbers that are both negative. So we could have -1 and -15. That would give us +15. But that's not going to give us -8. The other one we could have is -3 and -5. -3 multiplied by -5 is +15, and -3 minus 5 is -8. So these are our two numbers that we're going to use. So to factorise this, we'll be left with x minus 3, and then our other bracket is going to be x minus 5. And just like before, if you want to check my answer, if you want to verify this, you can expand the brackets and then simplify, and you should be left with this original expression here. Okay, so now it's your turn to get a bit more practice. So what I'd like you to do is pause the video and have a go at factorising these 5 quadratic expressions. Okay, so I'm assuming you've paused the video and had a go at those 5, so let's go through them. So first of all, we need to find two numbers whose sum is +8 and whose product is +12. So first of all, what two numbers multiply together to get 12? Well, I could have 1 and 12, 2 and 6, 3 and 4, but the only combination of those that give us a sum of 8 will be 6 and 2. So to factorise this, we will have x plus 6 multiplied by x plus 2. And if you did put x plus 2 and then x plus 6 after, that's absolutely fine. It doesn't matter which order you put these brackets, because multiplication is commutative. So 6 times 2 is the same as 2 times 6. So the order does not matter. As long as you've got x plus 6 and x plus 2 in some order, then that is correct. Okay, the second one. So two numbers whose sum is 11, +11, and whose product is +28. And those two numbers will be 7 and 4. So we're going to factorise this as x plus 7 multiplied by x plus 4. Okay, number 3. So this time, two numbers whose sum is +3, but at this time the product is negative. It's -10. We know that one of the numbers has to be negative. And because the larger number here is positive, the bigger number has to be positive. So we're going to use 5 and 2, because 5 times 2 is 10, and then it's going to be +5 and -2. So x plus 5 multiplied by x minus 2. And again, you can check all of these by expanding the brackets. Question number 4. So this time we need the sum to be -5 and the product to be -6. So again, one of the numbers has to be negative because our product is negative. But this time the sum is negative, so the bigger number has to be negative this time. So we're going to have 6 and 1, and it's going to be x minus 6 because the bigger number has to be negative, and x plus 1. So -6 times 1 is -6, -6 plus 1 is -5. And the last one, the sum has to be -8, and the product has to be +16. So the only way we can get a positive here and a negative here is if both of them are negative, because two negatives give us a positive when we multiply them together. So the numbers are going to be 4 and 4. So it's going to be x minus 4 multiplied by x minus 4. Or you could also say x minus 4 squared. These two are exactly the same thing. So hopefully this video helped you understand how we factorise quadratics using this sum product rule. But what you might be wondering is, well, why does this work? Why is this the case? And it's not magic. There is maths behind it. So in the next video, I'm going to go through why this sum product rule works for all of these different quadratic expressions. I'll see you in the next video.